All right, everybody. How are we doing tonight? This is Thomas's Torture Time. I'm Thomas. We have our best friend Perry here with us, and we will be shortly rejoined by our best friend Don Don. Here we are.
Hello,
So,
hello.
everybody, how are you doing tonight? Thank you for sharing an evening. To future listeners, how are you? Um, I'm just going to jump right into it. I've got my PDFs for textbooks pulled up for science and physics on multiple websites. I'm using Wikipedia. I'm using Science Direct, physics.org, Scientific American, and a couple of other places. So just so that y'all, if you need any specific sources, email me, text me, whatever. Who cares? But we'll figure it out. So last time, Perry, we talked about astronomy and the branches thereof, right? We talked about like astrobiology. We talked about uh,
Mm-hmm.
let me see what remember which ones we were talking about. Oh yeah, that's right. Yeah, we were talking about astrobiology. We talked about astrophysics. We talked about cosmology, which is really important. We talked about physical cosmology. We didn't really talk about like the structures of galaxies and things like that in terms of astronomy, but you know, just know that that's a part of it. The that we are in the Virgo supercluster. Our galaxy is just a small part of that, which is just a small part of other bigger networks. We didn't go too deep into that, and it's not necessary. Just go study your cosmology, go study your physical cosmology, and learn about this stuff. And I think you'll really be enriched by it. So tonight we're going, and as always, we're physicalists tonight, right? We can question it, we can be idealists, we can do whatever else we want to, but we're assuming physicalism to talk about these subjects. So,
Yes.
physics, right? What is physics? Okay. Well, I mean, basically, it's the one that all others supervene on in terms of natural sciences. Chemistry, biology, hell, even geology. Everything comes down to supervenes on physics. Physics is what is happening in reality. We are a part of reality, so physics is happening in us as well. So there is kind of like a synergy. We are physics. That's an interesting thing to think about. Are the cells in our body, the cells in our brain, everything that happens to us is physical. It's based on the laws of physics. Now, the laws of physics are the things that we are attempting to measure. The physics itself, which is the human construct, is what is measuring those physics with mathematics. That is how we should most easily look at this. Does anybody else have a better framework of looking at it?
Mm-mm. No, it just if our task is to measure the observable and to make laws and predictions about it, physics is the way we go about it. And to do physics, we do the same way. We try to measure
Right,
and make sense of it. This is what we do.
right.
There's no other way of doing it. You're not gonna figure out the speed of gravity by throwing rocks through that wall.
So the the easiest way to explain physics to everybody is that it's obviously an academic discipline, the most academic of disciplines, and it's the study of matter, motion, and space time, pretty much, and energy and force. But that's because of matter, motion, and space time. Uh, More broadly, it's the general analysis of nature. I mean, how we understand the universe is directly from what we understand about physics. Everything is physics. I can't pound that in enough. If you're trying to separate something from physics, that's physics. So it's very difficult to get past. It sets up paradoxes if you try to not use physics as the basis. Um, so we've got, I don't know which one I want to cover first because we have so many different disciplines that fall under physics. And of course, astronomy is technically about physics because you're studying, you know. Let's see about if we've got. I wanted to study this part. So we have things like, okay, so in physics, you've got basic ideas, right? I don't know if you guys have heard of Newton's laws of motion, but things like F equals ma, force equals mass times acceleration. What mass is, the density of an object, the force is, which is an applied field of gravity or electromagnetic radiation, and weight, how much the mass and force create weight. Um, Things like momentum are are observed in physics. Conservation of mass and energy, uh, which is matter can neither be created nor destroyed, which is an interesting thing. This is a philosophical question here, guys. What does created and destroyed really mean? What does it mean in natural reality to be created?
Transformed.
Transformed. So
I think that all it really means, I mean, it assumes that you're not going to from an absence, from a literal absence, from the most like radical conception of absence, things aren't going to materialize.
mhm.
That's really all it's saying. So like, and it usually makes sense within like when you think of in physics. The way I learned it was about systems, right? So you have like in
Yes.
a closed system, energy or matter is not going to escape or find its way in. Like for example, if our solar system was a closed system, no life would happen. But because we have our sun, we have a continuous energy source, and
Mhm.
it's an open
And
system.
we're very much in an open system, yeah.
Correct.
Everything affects everything when it comes down to physics, and we'll talk about this later in quantum mechanics. But go ahead, Don. I didn't want to interrupt you.
No, that's all I had to say.
Yeah. So, guys, when we're thinking about this law of conservation of mass and energy, that's why I kind of wanted to go deeper into the creation and destruction ideology. Why do we even have these concepts of creation and destruction in our mindset? Why did that happen
They're
mentally?
useful. They're useful words to use.
Okay, they're
I think
useful.
it's maybe a very classical mechanical view of the world where matter was thought to have been destroyed, but we didn't quite have this idea of the equivalence between
Travis, you're really
matter
quiet, bud.
and energy.
That's no, no, no. That's me. I got it. You can go
Oh,
now. I lowered you because you were banging around earlier.
oh, sorry. Yeah, I know. Maybe it has something to do with like this more classical mechanical view of the world where um, when we see matter destroyed, when we see something blown apart and blown up, like it feels like destruction, even though from a physics standpoint, it's just changing form, right? Um,
Mm-hmm.
so, maybe it's when we start viewing things in its truest sense, at least as far as we've gone, we're starting to view things through the lenses of quantum mechanics. So this idea of destruction being applied to matter is something that doesn't make as much sense anymore if we're looking at it through this
Right.
microverse lens.
I may even be asking more of a deeper philosophical question of where did the words or the concepts of creation and destruction emerge? And I'm kind of taking us off topic here from physics, but I think it's an important question because that is a part of the law of conservation of mass and energy. Create the idea. So, what does it mean for something if there is in fact a way, like, okay, so we can create a work of art, right, where it emerges from our intention. But is there anything in natural reality that you could ever ascribe the label to creation or destruction?
Again, unless it's you're just using it as a useful way, as Travis was saying. Once we thought that things were destroyed and created, if we actually think of something being created out of nothing, like Don Don was saying, no, I mean that's not. I don't. I tentatively don't believe that that's a thing or possible. It just transforms from one state of matter to another. I mean, we get these concepts from the pre-Socratics and Aristotle with the unmoved mover and creation, right? It's
Well, yeah, that might be true when we start thinking about black holes and what they do even to information, right? Um, whatever is on the the horizon of or whatever's at the end of the plumbing, right? In that toilet flush that the black holes are, that may in fact be a place that we see destruction, full destruction, and maybe new creation on the other end. But it may be the fact that it's just in flux and connected to other uh, realities. So it may be the case that there is no creation and destruction in the quantum mechanical sense anywhere. But of course, I think the concept is useful. And when you ask about the etymology of it, um, you know, I do think of ideas of, you know, chaos and order, and also religious ideas that have helped us to conceptualize reality around us.
I think Travis brings up a good point with information and black
Yes,
holes. If anything would be created or destroyed, it would be the information that is either being created from nothing or it
correct,
ceases to exist.
correct.
So, what happens to that information or
That's the
particles,
yeah,
primary
that's the
substance?
black hole. I'm sorry.
Go ahead.
That's the black hole information paradox, and I was actually going to bring that up in the next few episodes. Basically, people who are listening, the black hole information paradox is saying that through the holographic principle, um, the information of the universe is encoded on a black hole's event horizon as it
What does
sucks.
that even? What does that mean? The
So
information. is organized?
information in physics is seen as the shit that is like firmware that allows atoms to combine to be molecules.
Right. It's kind of a way of talking about the physical laws, like at least in a more colloquial conversation about physics. I hear people kind of talk about information as though it is the laws of nature as written, at least in its, you know, current form.
Is information then not matter? It's what tells
I'm
matter
not sure.
what to
I'm
do.
not sure. It seems kind of like noumena, right? I get that like just slight feeling from even saying it, but I don't want there to
Yeah.
be any mysticism around it.
Yeah, that's interesting, Thomas. I think it is kind of that the presupposition there being like, or just the claim being that we can call information whatever is at like, if we're using like the idea of what a computer simulation would be, the actual data that is underneath what is
Yes,
being observed. You
yes.
know,
And the question is the data in the black holes safe, which would be a good thing, hidden, or lost? If it's lost, we've got to rewrite physics. If it's hidden, then there's something specific we're missing, and then if it's safe, then there are theories that we're using that are correct about observing black holes.
Would you say if it's lost, that means it's destroyed? Or does that?
Yeah, and that's what I was going to get to. Perfect, perfect. I don't know. What do you guys think?
I don't know.
That's,
I mean,
that's one of the big questions right there.
yeah, I think this is some of the strange ideas we have from infinitely dense points, right? What does it mean to have an infinitely dense
Well, that's why singularities are theoretical. We don't actually know if there's singularities in the middle of black holes.
Sure. Yeah.
So
Yeah.
I can't even imagine what infinite density would be. Go ahead.
Well, it's an interesting thing to think about, because if we, you know, if the black holes are the whirly toilets of the of space and the cosmos, then you know, what does that plumbing look like, right? Like what how many junctions are there? Does this plumbing lead to other toilets? Does it mix with other toilets? This becomes a very interesting, and I mean, it's a funny way of thinking about it, but I do kind of think in that toilet analogy. But what we, unfortunately, the only thing we know now is that there's water in the toilet bowl, and it is spiraling. Well, there's matter in the toilet bowl, and it's
Well,
spiraling down. You know.
Well, you know, this entire mode of conversation, I'm still thinking about this information breaking down at the swirly twirly of the universe. And wouldn't that information breakdown just give us insight into the fact that there's a more fundamental information that governs that information that even lets it even be breaking down to begin with?
That's exactly why I currently hold a positive belief that no matter how many onion layers you pull back, this thing, and it sounds insane. There is no bottom. There is no center to this thing. That's what logic tells me thus far. But all I have is the logic we've created thus far. So
It's swirly all the way down. Is that what you're getting at?
Yes.
Well, maybe not, right? Like the idea of black holes and white holes, and how it may just be, you know, obviously we have the flat plane of space, right? space being flat is
Mhm.
what our best theories say. It's like on the other, when we start thinking about like, oh, the other side of flatness, or the other side of where black holes tend to be regressing too, like, is there a white hole on the other end where that information is just recycled again?
Oh,
And
that was a good rhyme.
yeah.
Classic men thinking about holes.
Well,
No, Travis, you're right. Go
the
ahead.
question that came to me with what Don said, would there be information about the spiraling down of information, that loss of
Yes,
information? Is there information about that information being lost?
I think so, but I
Theoretically,
don't.
yes.
Yes, I mean, yeah, I think so. I mean, there's got to be some meta information to what's being taken away.
So then there's going to be another set of information about that information, talking about the loss of information, and then
I'm
another
an
set of
influences.
So I mean, this was Aristotle's, intelligent critique against Plato.
Certainly.
If there's a form of the number one, then there's going to be a form of the form of number one, and
Yes,
then it's and how can that be if forms are essential and static and whatnot?
that's right. I mean, I'm an infinitist, so I'm fine with nature being a paradox, a bunch of fractal paradoxes all the way up and down.
It,
So when you look at information, it's just going to be like that.
Look,
You're going to get this meta information, right?
I mean, Aristotle was just
I was going to say
obsessed with,
Aristotle again. Yeah, go ahead.
right. Well, he's just obsessed with empiricism, right? So he's gonna want to peel that onion down, 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 just like we all want to, right? Like anyone who loves science is going to be in the same shoes as where Aristotle would be at this age of quantum mechanics, and
Or
really,
Epicurus.
yeah, exactly.
Yeah, I'm a good Aristotelian when it comes to empiricism and science, but I'm a good Platonist when it comes to reasoning and definite. It sounds like this information is Aristotle had an idea of forms, idios. Also, it wasn't just Plato, but Aristotle's forms were within the matter, within the squirrel, within the acorn, and that's
Yeah.
kind of what it sounds like information is. How we're describing it, kind of similar.
It
Aristotle,
does. It
yeah,
does actually sound exactly.
Aristotle wanted to make those forms more concrete and less,
Right. Yeah.
less wavy on the outside. But what's really funny though about that, like take Plato's idea of like, kind of more, this vague array of forms. Take Aristotle's, empiricism. Which one was more true to reality the way we see it now, or best understand it?
Yeah, it was Aristotle, of course.
Maybe. Well, what about the vagueness of those boundaries between, and what I'm talking about, Perry, is like, as we move down the logarithmic scale, when we get down to like little fundamental building blocks, when we get down to gluons, right? It's like, that line between forms and like reality fabric is not so clear, and maybe becomes indistinct at some point, or non-distinct.
Yeah, I just don't. I'm not convinced that there's a heaven in which, this bottle opener is appealing to. I think that it just is here. It just is primary substance, and again, like I said, I'm a good Aristotelian when it comes to ontology, but when it comes to epistemology, that's where I like Plato. I don't know. I mean, what do you mean by the gluons? Are you trying to get at that there's some essential Urstoff or substance, like there's a primary substance or something
Well,
with
But
those?
wait, didn't we start out with the agreement that to do physics we just have to kind of think it that way to do good physics?
So think which
Oh,
way
yeah.
that there's a primary substance.
I guess so.
Like he's saying a primary substance as in physicalism, idealism, neutral monism, substance dualism.
Yeah, right. That there's, if it's not infinitely dense, that there is some indivisible atom that's, the hydrogen atom, right? There's one, that's one proton, right?
Yeah, one electron, one neutron.
And all other elements also have at least one proton. That's just an analogy. We know that hydrogen is not the most fundamental thing, but I mean,
so that's something to explain. Tell everybody, is that a proton is in every what now?
on the periodic table of elements, there's at least one proton in every element, right?
Yeah.
So
Yeah.
just as an analogy, that would be considered the primary substance,
Mm-hmm.
right?
Protons.
But then,
Right.
but
For
then each
example.
proton is made out of like up quarks and down
I
quarks or whatever.
and I can't emphasize the fact that this is an analogy more.
Okay.
We were talking about gluons, for example, perhaps gluons or something. One of the 13 quantum mechanic elements that they have. I don't know all of them, right? But I think there's 12 or 13 of them.
The reason why I said gluon is it being a force carrier. I think there's something about, there's something interesting about matter and energy, but getting back to information, like information itself about the fundamental forces, that's where my mind goes to, like, and that's why I pointed out gluons. Like when we get to the force carriers, I think we're going to start seeing more discoveries in the force carriers than in matter as we peel this back, because I think it seems to be gravity in most people's mind is a force at this point.
Mm-hmm.
And
there could be a corresponding particle, maybe.
Yeah, and but what we can say is there's an undiscovered territory with regards to gravity. And if nature is quantum mechanical, then there should be a particulate representation at some level. So, yeah, when we talk about like discoveries or what may come, what may give us more insight, I often do think of the force carriers and what it might tell us about gravity.
And that's kind of like information, the force carriers.
I think it can be looked at like that. But of course, the points you guys brought up, it's like, what about the information of that? What about the information that allowed that plane, right? And that's why I just say, to get away from that, I just say state of potential. But that's
it may be one of those things like, can God create a rock that he can't lift? Like maybe it's just not worth talking about those paradoxes. Maybe it is worth. I don't know how that would help us if it's just
any pragmatist.
Well, if there's some kind of meta,
exactly, it's pragmatic. Just
any pragmatist is going to say fuck off with that.
Well, right, I mean, exactly. If there's some kind of meta information to be understood there that's being taken into a black hole, then I think we need to take account of that. But I mean, how far up the meta ladder we go is dependent on how far we peel the onion back. Go ahead.
Yeah, how far should we extend our God's eye view of the black hole, right? I mean, is there...
Because remember, if we get down to the Planck level, if we get down to Planck units, Planck time, Planck length, measuring below that gives us black holes. It gives us that infinite density, limit.
Oh, man, that's another thing that I don't want to necessarily tangent off and just, but I can imagine dividing the Planck length by 2, but there's something about the math that tells us below the Planck length is a black hole. Now, empirically, we can't even see the Planck length, but if we had the technology, do you think that if we zoomed in a little bit more from the Planck length that we'd see a black hole? Or is that just what the math, like, is the math leading us astray sometimes? I get it that it's very helpful in most cases.
Yeah, we're going to have to rewrite math to fix this problem. So you're pointing out an extremely important thing.
Yeah, that seems to be, well, what they would say is you shove 2 fundamental particles close enough together at the Planck length or on the Planck scale, you eventually have the spot where math breaks down. And that doesn't mean that we'll never have math to explain that, but it might mean that we go into a new domain of mathematics when we get to that point. To better understand
I'm fine with that. I'm 100% fine.
We've had to rewrite mathematics quite a few times as it's grown over the hundreds of years that we've been doing it.
Yeah.
Humanity anyway.
It was like half a year ago, Travis, you posted a video of Brian Greene and Sam Harris talking about quantum mechanics.
Yeah.
And what string theory doesn't have is that empirical observation. but I've also heard a lot of not negative, but just bad things about, not bad things, but it's not looking too good that string theory is right. Maybe it needs to be
Yeah,
tweaked. I don't know if they throw the whole thing away,
you
but
know,
yeah,
yeah, that's string theory's got a problem of it 10 to the power of 500 possible iterations of vibrating strings. And the reason that that's a problem is that's not something you can do anything with.
yeah,
That is, it that doesn't necessarily mean it's wrong, but that doesn't get us any closer to understanding. So
I would say that makes it wrong.
yeah, I mean, some people do say that. Some people do say like, okay, there's 10 to the 88 particles in the known universe,
right,
and we're talking about not even in the same universe of of uh, of mathematical possibility. So essentially, like 10 to the power of 500 is like, some people would say that, oh, that means anything's possible. No, that wouldn't mean that. That would mean that there's still a limit on it, right?
I mean, that's 500 zeros. I can think of 10 to the power of 5 quadrillion, right? So, I mean, my
Exactly.
mind can get crazy.
Yeah, exactly. So it's not, and whenever we try to put a limit on reality like that, I think it's a mistake. Even though I think the closer, here's the crazy thing about it. I think the closer we get in mathematics to accepting that there's probably an infinite regression here anyway, that we're going to breathe a deep stank sigh of relief that we've been holding on to for a long time, and we can get over certain things. But that's not anything new. That's just, I think, like Lawrence Krauss said in our least recent discussion, he said that we all still want to view the world through a classical mechanical lens because it makes easy sense to us, right? Apple fall down from tree. Apple don't fall up from tree, to quote
Yeah,
Nimick.
yeah. Let's slow down and explain this for people real quick. So, classical mechanics, guys, is what physics was for hundreds of years until they figured out the quantum interactions, and then you have quantum mechanics. So,
Right.
classical, quantum. I'll explain in a moment Newton laws of motion, but go ahead, Travis.
Yeah, and all I was getting at is like, yeah, like when you look at classical mechanics, classical physics, these are the things you'll learn about why a ball is moving the way it does down a little ramp, and you can
Hmm.
calculate it, and you can get the right answer, and you're like, yes, we know it. And what we know now, and what we should start thinking about, we should start looking at the world in a quantum mechanical sense, because that is the world, that is reality. And I used to say something along the lines of like, um, we don't, that's a reality we don't interact with. But I think we have to start getting over that idea, because our technologies are taking, like, are using quantum mechanics, right? Like,
Yes.
we're doing that. We need to understand it, because that's what reality is. Um,
Hmm.
and
I
I
think in
and I
200 years, the
yeah,
Heisenberg uncertainty principle might not be so uncertain to us.
yeah, and I also think like there's there's a romantic notion in understanding that there is a quantum mechanical realm underneath these things that seem so simple. There's an appreciation for reality that can come with coming into contact with the evidence we've unveiled about quantum mechanics. That is, I think, much more romantic. Reality is not so surface. It's deeper than the oceans of our heart. Is quantum
Mhm.
mechanics.
It really is. That's a beautiful way to put it. So, yeah,
let's see what else we can get on topic with or talk
yeah, let's
about.
get back on topic. Okay, so I'm just going to explain really quick, guys, the foundations of classical mechanics. Newton's laws of motion are three basic laws. Classical mechanics, they describe the relation between the motion of an object and the forces acting on it. A body remains at rest or in motion at a constant speed in a straight line unless acted upon by a force. A body, everybody, is like looking at things in terms of systems. And I will get to system science in another episode, but systems are just mental constructs Okay, so when you're talking about a body, you are talking about a physical object, right? This is where we have to get physical and say, okay, we're
Let's
throwing
get
a big part of philosophy
physical.
out. We have to just assume that we're talking about physical things. So, number two, when a body is acted upon by a net force, which could be electromagnetism, gravity, whatever, the body's acceleration multiplied by its mass is equal to the net force. The third rule is if two bodies exert forces on each other, these forces have the same magnitude but opposite directions. Okay? So these three laws of motion were first stated by Isaac Newton in his Principia Mathematica, which is the mathematical principles of natural philosophy. He published that in 1687. Newton used them to investigate and explain the motion of many physical objects and systems that he had observed, which laid the foundation for classical mechanics, classical physics. In the time since Newton, the conceptual content of classical physics has been reformulated in alternative ways involving different mathematical approaches that have yielded insights which were obscured in the original Newtonian formulation over many years. Limitations to Newton's laws have also been discovered. New theories are necessary when objects move at very high speeds, special relativity, are very massive, general relativity, or are very small, quantum mechanics. So that is what we're mainly focused on today in the theoretical work in all the theoretical scientists, theoretical physicists. They're worried about special relativity, general relativity, and how quantum mechanics maps to all of that. We're looking mainly, the big question is there a particle for gravity? Is there such a thing as quantum gravity? Is string theory correct, just like Travis and all my friends were talking about a moment ago, which we can go into further about that. These are the foundations of physics itself. So we talked about the laws of motion. We talked about mass, force, and weight, momentum, the law of conservation of mass and energy. We talked about gravity a good bit, that it's a force, right? A good way to think about it is that matter warps space, and then the warping of space shows matter how to follow the curve.
I
Would I
actually
say that?
did a presentation on that one time in physics class.
Yeah, go ahead.
And the way I would do it is I took like a bed sheet and I had people hold like each corner and I would put like marbles and balls on it and like show how things attract to each other when they have mass or something like that.
Yep.
That
No,
is
that's
perfect.
right. Yep.
Now, I know exactly what you're talking about. Is that actually what gravity is doing when massive objects, they have mass and they kind of fall along this fabric, this blanket that you were pulling? Is that
Mhm.
is that that's how is that a good analogy? I mean, I
It
get kind
only
of
shows it in the 2D.
okay, so I'm imaginative enough to make that 3D,
Yes.
and
That's what they're
so
talking about, is like a three-dimensional fabric.
that fabric is a good representation to the fabric of space-time.
Yeah.
So objects with mass will fall along kind of to the center of the blanket, right?
Mm-hmm.
Is that like is that a sound representation, or is it just kind of helpful in
I
helping us
think it's
imagine it?
helpful to abstract it because we can't really show what the fabric of space-time would look like in 3 dimensions with like bed sheets and marbles. You know what I mean? Because there's three vectors. There's three directions.
I get that part. I get the 2D,
Oh, sorry.
how it's
Yeah,
2D
yeah,
and
yeah,
whatnot.
yeah. I'm just talking for the audience. My bad.
Okay, I think I don't know what to think. I mean,
Why don't you know what to think?
I,
I
I
mean,
don't. I
is it actually a representation of what's happening? No. Is it a way to understand it? Sure, but then
right.
isn't everything just a way to understand stuff of what's actually going on?
Well, sometimes we can make some experiments that are the actual thing that we're talking about, just at a smaller or bigger scale.
Yep.
I mean, we can drop a tennis ball and a balloon in a vacuum, and they're going to fall at the same speed, right?
Yeah.
Similarly, and we can drop a bowling ball and a pebble not in a vacuum, and it'll still drop at the same rate, right? Because
Hmm.
they're just not.
Mm-hmm.
But those aren't. There's still air friction. I don't know. I think I have.
When you drop a tennis ball, it's being affected by every other physical force and wave particle that's happening out there. So you're getting a bunch of different vectors in the fabric of space-time as it's falling.
That's a good point. So what if we had a huge blanket and we just threw a bunch of shit on the blanket, right? On
Yeah.
this, would it still act as gravity does in a similar fashion, or is it just merely
I don't
a
know.
good?
As the things get closer to the center of the blanket, they start to warp downwards the blanket. You know
Right.
what I mean? Because so that's the way it's looked at when everybody gets explained general relativity. That's how they get shown. Is that example that Don Don's talking about?
Okay.
But
Anyway.
I just don't know how you could, maybe like through a computer representation, you could show people how
Yeah,
the fabric of space time is three-dimensional.
probably. Yeah.
Yeah. I'm not sure though. I'm just as confused as you are about it, so don't worry. We do know that gravity is the weakest of the four fundamental interactions, and it's probably good to bring that up now, even though we've talked about it in the past. You have the strong and weak nuclear forces, which hold the nuclei of atoms together, and then you have gravity, which we've just talked about, and then you have electromagnetism, which is all forms of photonic radiation that we get to our eyes and everything, radio waves, gamma rays, all that stuff. We already covered that. Anyway,
it's important to say in gravity too that dark matter, the ideas of dark matter arise due to this repulsion, gravitational repulsion, that we see, and I believe lensing. So that's when we get into more complicated views of where we see gravitational effect, where we don't see any matter, so we call it dark. Dark matter makes sense there. But
yeah, we measured the universe, and it says we should have a different weight than what we do, if you want to say it that way. And the shit that we can't measure that doesn't reflect anything is dark matter.
Right, but there is there's a gravitational interaction of some kind.
Yeah, there's something going on there.
Yeah, which is how we can detect it, right?
Yeah, same thing with dark energy. It's a pushing force, but we don't, or it's an inducting force, I guess you could say, because it's pulling itself in some way.
Okay.
But no, dark energy is like 67% of the cosmos. Dark matter is 20 something percent, and then regular matter is like 5%. It's really small. I can't remember.
Yeah.
We'll look it up in a little bit, but it's a lot. I do know that dark energy is like 67%, and that's what's pushing. Just for the audience, that's what's pushing the the galaxies further and further apart. That is what's making things further from us accelerate quicker and quicker and quicker and quicker until it's way faster than the speed of light. That's why we can't see that shit. That's why we say we have an observable universe, and we can't talk about the entirety of the universe, because shit's going to be eventually so far away from us that no light will be the only galaxy in a vast black ocean. If it goes that far, based on our current understanding of physics.
Wouldn't that mean that there's a point where it just accelerates so fast that it just says?
Well, eventually, after a long enough time, if it doesn't get sucked into a black hole, all the matter would just like pull apart.
Right, and we're talking like cold.
Yeah.
Well, yeah, it'd be just above absolute zero, right?
Yeah, I mean, I don't know.
Cold.
I don't know if space would get to absolute zero. I don't know about that. I think
as long as there's matter, it would not be absolute zero. That's why I said just above absolute zero.
Wouldn't it be as long as matter is hitting each other?
Well, as long as there's work to be done, because that's what energy does on matter.
As long as matter is moving, right?
Yeah.
It's got to be moving.
Yeah. See, entropy, the heat death idea, is that everything will be thermodynamically equilibrated to where it's like...
and their fields are going to have to be further apart, right? Because fields themselves are heat, as I've learned.
Yeah, fields can carry heat, yeah. Or at least, what was it that we read the other day? Fields can... they can have force and momentum, and they can have electromagnetic charge. Well, that's the electromagnetic field. Then you've got other... I don't remember what we read. I'd have to pull that up again.
What's a field?
So, okay, let's explain that for everybody. A field, one memento. We're just going to go to Wikipedia real quick because that's easier than doing all the other shit.
That's how that works.
Field.
Actually, Thomas, can I make a quick point about that?
Please.
Everyone, please, it's okay not to recall what you think you might know about a topic and go and refresh yourself like Thomas is doing right now. Thomas could sit here and give you definition of a field and almost nail it, but he's taking the time to go and, check the information, see if there's something new you can pick up. Don't be afraid to do that. I see too many people like thinking that the goal is to commit things to memory and then think you're finished. You always, you know, check to make sure you're not forgetting a vital detail, because
Yes.
these are categories that depend on the vital details.
Be meticulous, be rigorous, challenge yourself, learn these things. Go and be obsessive about something. Learn something that you really care about. If you love physics, go get into this, right? I want to be like Perry said. I want to be a jack of all trades and not really take too much time on any one thing, because that's just the type of person that I am. But there are some people who love physics so much that that's all that they do, and they do it for a living every day, like our friend Lawrence Krauss. Or he used to. Now he's traveling and talking all the time. But
I want
so
to be a master at being the jack of all trades.
I think that's a good thing. So guys, Travis is absolutely right. In physics, a field is a physical quantity represented by a scalar, vector, or tensor, and I'll explain those in a second, that has a value for each point in space-time. So a scalar is an element of a field which is used to define a vector space. Think about like, the Cartesian coordinate plane, x and y axis. Just add one more axis to that, and
Z?
you've got a vector space. Yeah, y. Yeah, z. That's it. X, Y, Z. So then you've got a vector space. Okay, and a vector is a term that colloquially to some quantity. It basically is
Direction,
direction and quantity.
magnitude,
Yeah, direction and magnitude, direction and quantity. Whereas scalar is just
magnitude.
quantity.
Quantity,
Yeah, magnitude. Yes. A tensor is an algebraic object that describes a multilinear relationship between sets of algebraic objects related to a vector space. That's a little bit harder to understand because it's a calculus term. So I implore all of you to go look up what scalar, vector, and tensor are. They're easy. They're relatively easy to understand, but it's not. There's no point in going too deep into any one
Can
of
you read
these.
tensor one more time?
Yes.
And also understanding algebra too there, Thomas, right?
Yeah, you're going to have to learn algebra, trig, and calculus if you're going to do serious physics. That's just a fact. You're going to have to do that. I did it in college. I only got up to Cal 3. I didn't take differential equations or anything. But if you, I tried to study differential equations, but you need to go to school for that. You can't teach it to yourself. Really.
And also, one thing, if everyone who gets into physics believes that they have a theory of everything. If you think you have a theory of everything, please write out the equations and the mathematics for it, just to see if it's ever been done. Check your work, check plagiarism.
Yep.
Check all that stuff, because everyone thinks they have it, right?
I called out someone on that. This person is a real good interlocutor too, but they said, I've had these ideas which no one has been able to prove wrong. And I said, okay, well, did you get these ideas from math, like the mathematical equations, or something that you've seen, or was it just pure imagination that you kind of got it from?
Right.
And it wasn't either of the first two. So
Ouch.
Yeah,
but they weren't
usually,
claiming theory of everything, of course. They're a good interlocutor. So
you know what's funny about that, Perry, is oftentimes these intuitions we have about theories of everything, when we first start getting into it, make good logical sense, right? But then when people look at it and then they're like, yeah, that's a good like first thought, but then we got to account for this long list of things we know that are very complicated and are not like one-to-one relationships like your initial thoughts might suggest the cosmos to be.
right.
So yeah, it's like details are everything. And people like Michio Kaku, here's what happens. Michio Kaku on repeat, like, it just says like, we have a dream of finding a 1-inch equation to describe everything. And it's like, yeah. And then people go and like, write, they're like, yeah, everything is equal to this. And then they'll make an argument, like a logical argument about it. This is what, and you can do that. And it helps semantically. And the philosophy of semantics is very important in all of this. It'll help semantically to talk about the cosmos and what might be going on, but understand that like empiricism, mathematics, logic, logic and its application to science needs the goods, right? And this
Yes.
is where
Yes.
we need the goods. We need this.
Yeah,
we
and,
need
and
it.
if you remember, this is a fallacy. If you say, "Well, I'm going to believe this until it's proved wrong," that's a fallacy, right?
Exactly.
Because that doesn't necessarily mean what you believe is true.
Yeah. And also one thing to add quickly to that is that just because scientists haven't taken the time to assess your theory of everything, that doesn't mean you should be presenting it as like a like as something that like is worthy of that, right?
The
Like
new
send it,
prophecy.
yeah, send it to some physicists, and if they tell you to like not quit your day job in a response, that doesn't necessarily mean that they're scared of you exposing how right you are and how wrong.
Whoa! Are you telling me
right?
that Brett and Eric Weinstein are having don't think about things properly? Is that what you just told me?
How
Well,
dare you?
Look, there are people like that, and I think Brett does fall into this category, and sometimes Eric, where they start pointing the finger at how everyone else is wrong because I'm so right. And I don't think that's a wise way to think. You should really listen to your peers and listen to their objections. And if they don't satisfy you in their reaction to your grand piece of work, that doesn't necessarily mean that you are due the satisfaction. So I do think there's a lot of bad thinking around that, where it's like some people will just retract to, oh well, they don't think it's right because they don't like me, and this is why we have methods of mathematics and examination of physical things empirically, so that we can actually deduce right and wrong by our own scientific standards. So
Yes.
It's funny you said. I mean, we had Aristotelian logic for the longest time, right? Until the 1950s
long
or
time,
whatever.
thousands.
And you're right. Your initial intuitions, though maybe logical, probably are absent of the many complex and complicated other works that we have to consider. And what I think people do is, rather than kind of going into that complicated stuff, they see it to be mystical. They see it to be so
Right.
like it's not logical. It's got to be magic, and then other mystical intuitions come from there, rather than I don't
and
know.
then they throw it out the
ironic.
window and
Well,
start,
that's Arthur C. Clarke's rule: is any sufficiently advanced technology, or I guess you could even say biology, would be considered magic to someone.
Yeah,
it's
exactly.
advanced enough.
And look, the Large Hadron Collider is a good example of this, right? Like, take the information of the Large Hadron Collider and what it is, take
Yeah.
it back 1,000 years, try to describe what we're doing. They're like, oh man, you the devil, man. Like
Yeah.
they don't.
You the devil.
Why are ancient people either Southern?
Well, they'd be English. They'd be talking in like Shakespearean, like
I hope
English, old
Thomas-
English.
I hope Thomas is the one to destroy that stigma of people from Alabama not knowing fuck all about shit. Like,
That's what
Thomas could
That's
be-
what I'm trying to do with Florida. I'm trying to give the Florida man a new meaning.
Wow.
Florida man, Florida philosophy man.
Reclaim Florida, man.
I'm trying to. Yeah.
Honestly, you should you should rename your YouTube channel to Florida Man Philosophy.
Are you a meth gator?
well, whenever I refer to Thomas to someone, I refer to Thomas as Thomas of Alabama, like so it's Perry of Florida,
Yeah.
Don of New York. Like
That's a very ancient way to do things.
I like that.
it is.
It's like we're in
Yeah,
Israel.
but I think it's fun. Look, we can't throw all tradition out the window. I mean, Christmas is a good time.
even though it's a pagan
I mean, it's
holiday.
it got canceled technically, right?
Science,
We can't even
science
say
and physics is like, okay, every 100 years we're pretty much going to throw out all of our traditions. That's pretty much what happens with physics and mathematics. All right, we're going to throw away the old traditions and scientifically use the process to get new traditions, and then try to go on from
That's
that.
actually an interesting thought. I wonder if we could actually get any insight by doing some exercises like that, not full on like throw everything out. I wanted to say something also in the very beginning when you said we are physics. That is a reason why I have trouble identifying what the I or the self or what
Mhm.
freedom is.
Mm-hmm.
Just of a thought, a forethought that I had that went to the back of my
Well,
mind and is back.
I realized my folly for many years in thinking that there may be a mind dependent and a mind independent. That assumes substance dualism, that the two things can't interact, or property
Right.
dualism, where they do interact but are still separate substances. So I'm going to try to get away from saying mind dependent and mind independent. Maybe we can just get away with saying subject and object. Right.
Yeah.
Even though I believe that the observer is also the observed, because
That's
we
fine.
are nature. I'm going to try to be more succinct and say subject and object, because mind dependent may be mind independent. I don't think the a priori and the a posteriori are separate. I think
Thomas,
they are in tandem.
that
agree.
is so correct, and exactly why I think the vernacular, even the intellectual vernacular, has started treating things as things born of the subject or objects in and of
Yes.
themselves. I think that's
Yes.
so right.
Again, I guess if we were just to use subject, it's kind of presupposing this thing of the self.
Yeah.
I think. I mean,
Yeah.
I think we are objects, not to put it derogatorily,
No.
but you know,
I mean, our
Yeah, but-
mind is an object, and that's
Yeah.
where we think. Excuse me. Our brain is an object, and that's where we think the mind comes from. But what if we find out that's not where mind comes
I
from?
was going to ask a poll, do my weekly at everyone, and I was going to ask, where do you think the mind is located?
Well,
Yeah.
I mean,
Maybe I'll do
if
that next week.
anyone who claims the label of physicalist, like I do, is going to that means your intuitions are to claim that everything is physical. Mind does not escape that.
Hmm.
Mind is physical in physicalism. That
Yep.
is to mean that concepts themselves, information itself, is going to hold a material physical representation. And where would that representation live? For me, it lives inside the brain. Now, it's possible that that's not the case. It's possible there is some kind of dualistic reality going on here. But I think everything we have peeled back in physics, we have not found non-physics, right? What would that even mean? That doesn't mean it doesn't exist, but
Well, we must
Yeah.
always remember that there is no physical experiment that we can do to prove that everything is physical.
so far, yeah. And
far.
and look, I think even that will almost certainly always be the case, right, Thomas?
Yes,
Like,
yes,
I think
yes.
like again, this is the onion problem we're faced with again, which is reality is just a never-ending onion. Whatever, that's probably right.
No,
And
I
the-
like that. I mean,
Shrek
that's a good
philosophy.
analogy.
Yeah,
Go ahead, Dun Dun.
Shrek philosophy.
You, I don't know if you did this purposefully, Travis, but you said the mind and concepts are material and physical. I don't know if they are material or matter. I don't know if how you use those words, if you equivocate something like gravity, for example, is physical. I don't think that it's matter. Carnap came up with the idea of physicalism to replace materialism that
Yeah.
was used forever by Democratic.
that's why I said it. So those who are stuck in the ancient, I've noticed in physics or in philosophy conversations, like those who are stuck in the ancient idea of like being a materialist as opposed to a physicalist, as though those are two separate things. They are different, but one is just kind of like the grandfather of the other, right? Wouldn't you say?
I guess it. I mean, we would have to do the whole Gödel's incompleteness theorem of linguistics and say, what do you mean? You know, how would you define matter, and then how would you define the words that you define with? I mean,
Right.
are you just how you use it? Are you just synonymizing physical with material, or
Well, physical, when I talk about physical, I'm talking about everything that is as a physicalist.
that's fine? But what
Yeah.
about matter? Is matter also everything that is? Then
Matter, no, so matter
fair
isn't,
enough,
right.
right? Okay.
So matter is not time. Matter is not space. At least, it might be matter, might be materialistic, but yeah, I think time is more. Time is the change of those states.
Causality is
Yeah,
not matter, and
right,
causality
exactly.
may be separate from time, or it might be
Yeah.
synonymous with it.
It's like information or energy. I
This
mean,
is what.
like,
Yeah.
Well, matter and energy are the same thing. So
This is why physics, I think, is the most accurate label of everything, of reality, right? Like when we say it's like it's physics, man. It's like people are like, "What is reality?" Well, it seems to be physics.
yeah,
That's what it seems to be. Even if we're talking about information being physical as well, which is
um,
just yeah. Go ahead, Barry.
God bless it. You said that matter and energy are the same thing.
Yeah, in
That's
special
interest.
relativity.
That's interesting.
yeah.
So we talked about time, space, structure. Oh, information. Yep, that's a good one. Forces, energy. Um,
Yes.
so it says physicalism encompasses matter. Matter we have in classical general matter is any substance that has that has mass and takes up space by having volume.
Yeah.
This seems to be somewhat conflicting, don't you think? Has mass. So physicalism encompasses things that have mass. Oh, okay, but
And
also,
everything else, right?
in addition, energy,
Yeah,
physical
exactly.
laws. Okay,
In
I see.
addition, yeah.
And then where was I thought the mind was up here, but again, something like a consciousness. Here it is. So I mean, consciousness and mind. I don't know if we equivocate those things. Perhaps not. But are concepts material
Yes,
or
that's what I
they?
believe. Yeah.
Okay. So they
Anyone who
have
doesn't. Oh, sorry, material. Um,
material? Yes.
yeah. So
Not. I believe it's physical, but not material. Personally.
that's a very interesting question, right? Like, can you like maybe the mind is a construct, much like how we wouldn't, like okay, we have an idea of what time is. Time is a change. If there's no change, there's no time. Imagine a solid state universe that never changes. There's no time in that. So time is change.
Right.
So if we're to say this new category of mind uh, is a abstraction from the processes of what the brain does, and we call that something different than material, sure, but what I'm saying is the mind will still be abstracted from some physical phenomena. I would say
Some.
just like change is a physical phenomena.
Okay.
That's my idea.
I would actually agree that. I would think even like our constructs, right? Like our normative constructs or our when you study psychology, like concepts of the mind are rooted in biomechanical physical structures in the brain and the rest of the body.
You're right, Don. It says even abstract. Well, according to this, you're right. I'm not going to say you're capital R right, but it says even abstract concepts such as mathematics, morality, or normative things, as you were saying, consciousness, intentionality, meaning. So that makes sense to me.
Conversations about physicalism can blow people's mind too. Like for everyone out there, if you want to have an interesting conversation, pull up the Wikipedia of physicalism and actually read what it's saying. It's profound to me, this idea that everything just might be physical. The love you have for your mother, that concept, that experience, holds a physical representation in the cosmos. That is a profound idea.
That's a beautiful.
But isn't
thing.
this what science is based on? Isn't this what science is based on?
The love for your mother, maybe.
I mean, no, science tries to find the physical representation to map it biomechanically, whether it be like
Yes.
biologically or any type of system, pathways, construct. There needs to be some sort of material representation, or else no one really takes it seriously. And vice versa, any material representation needs to have constructs and concepts to
Yeah,
define it and organize it.
that's correct. But philosophically, just as metaphysically as I can say this, and if we conceive of it this way, everything emerges from the physical, like taste, touch, smell, our empirical senses. If we were to try to touch the physical or taste the physical,
Mhm.
that's an immaterial thing. So the monistic substance of physicalism can't be experienced directly. Everything emerges from the physical stuff. And that's the real question that we have to get over when we go far enough back the metaphysical chain and question
Right.
these very foundational things.
Well, that's interesting because I remember speaking to Brian Greene about this, where he was faced with this idea that the physical things he has come to understand are just always in flux, but
Yep.
he doesn't want to hold a positive belief that he will never find the bottom. He will never actually solve the problem.
Yes.
And
Yes.
now that's where we start talking about, scientific being naive. What is it? Naive realism, right? Where
Yes.
someone might fall into this idea that, like, no, a ball is a ball in its true form and nothing else. Like, like
Yeah.
they,
Yeah.
you want to
Like,
naively.
what are all you guys arguing about? Shit's real. Don't question it.
Yeah, it's like, yeah, exactly. Which is funny because that's kind of against the spirit of the
Science.
scientific endeavor.
Yeah, it is.
You know,
So we can cover this really
Yeah.
quickly, and I think
Yeah.
Perry will appreciate this.
Yeah.
Change first appears in Greek philosophy in the writings of Heraclitus, right? With
Heraclitus.
Heraclitus. Can you pronounce it?
Heraclitus?
Panta
So-
Ray, everything flows.
Oh, I don't know what the Greek. Are you giving me a Greek word
Okay.
to pronounce? I
Yeah,
don't know.
it's his. I guess it's his writing.
Yeah,
go ahead,
change.
say what you were going to say a minute ago. I changed the subject on you. I didn't realize you had.
Well, it had something to do with kind of like the stepping in the river. That is an interesting thought that I don't know. I don't even know if I've even thought about that. That since everything is changing, how can we get to the bottom of it, so to speak?
Yes.
As Brian Greene
I
says.
think it's important to cover what. Excuse me.
Deleuze is an
process-
empiricist.
Let me just read this real quick so that we can understand. If I can find the fucking link where I have it. Okay, excuse me 1 second. Let me look this up. So
Don,
process philosophy is what we're looking at. Okay, process philosophy. Everybody
Well, I was
familiar
going to
with
say,
that?
Don had something to add there about.
Oh, I'm
Deleuze. I was
sorry.
interested in
Yeah,
hearing that.
yeah. Go ahead. I was
Yeah.
just powering through. I'm sorry.
Yeah,
I mean,
no worries.
Deleuze is an empiricist, and he deals with exploration of the natural world. That's his whole project. And he believes that there is no identity to material. There is no thing. It's always in a state of becoming. Right.
Yeah.
Yes, that's
So it's just better to just bite the bullet on that and try
that's
to
why.
learn the way.
But that's
the
why
world in that way.
concepts are static, because they're representations of those changing things. And if we need to use a different static concept when it changes so much, then we will.
Yeah,
Well,
well,
you
well.
as long as our
Yeah.
concepts themselves are fluid and can change, then sure.
Yeah, is that not why fallibilism should be at the very forefront of our thinking? Like how
Yes.
we should always be reminding ourselves that things are in flux, things are in a state of always becoming. That's what reality tells us. We are change. Everything is.
That's what I was
change.
going to explain to people
Yeah.
really quickly. Process
yeah.
philosophy is also known as the ontology of becoming, or processism is a 20th century Western philosophical school that focuses on the elements of becoming, change, and novelty. This is different from like Parmenidean ideas of like Western philosophical ideas of like being, permanence, and uniformity. So it's really between those two. It's between becoming, change, and novelty, and being, permanence, and uniformity. It's really like a demarcation line has to happen somewhere, and we don't know where
Right.
that is.
Right.
Mhm.
Yeah. Exactly.
God would be the only being, the unmoved mover, the static, or anything static, I guess, and
So
unchanging.
so we go back to the question: what is change really? You know what I mean? If everything is process philosophy, if everything is in a state of becoming, then is there such a thing as no change anywhere? Like, is that even a concept?
Well, I'm tempted to.
Ooh, I like that one. Is there such a thing as no change?
Well, I think in ideas of other universes, there are other hypothetical universes that don't include time. They just are in a state of unchanging. We can imagine this. We can imagine a space, a universe of space with no time. So sure we can have, and then an interesting an interesting question is can you have a universe of spaceless time
Hmm.
where there are these quantum fluctuations happening, but they have to be happening in something, right? So whether you call it space or a state
Well,
of
it
potential,
seems
whatever.
like time is emerging from space, mixing with causality.
Sure.
I always look at it like that in some way.
Yeah. Yeah.
Spaceless and timeless. I can get the timeless. I mean, that's what absolute
Yeah.
zero would kind of be. Everything is just
Mhm.
frozen.
Yeah.
Spaceless.
That's a
Well,
hard one.
There seems to need to be a canvas for anything, right? And the canvas seems to be dependent on itself, or always has been. So, to try to imagine a canvasless painting is
It'd be like a Platonic form
difficult.
outside of space and time. I mean, again, and beyond
God.
space and time,
Yeah.
or God, right? I mean,
Yeah.
even those things, it's hard to imagine without using our space-driven concepts.
Well, look, and I do write about this in my new book that actually probably be out in 6 months from now. I do talk about like this pressure of certainty we're always that is involved with us, and is a bug and a feature depending on what we're doing. But there is this solace for many in this idea of where change goes to die, and that would be the concept of God. Now, whether someone can make that work within their epistemology is another thing. Come to accept that, but if you can achieve it, which it may be an achievement even by a well-being standard, if you can achieve believing in this place where change goes to die, there is a this feeling of there can be this feeling of absolute achievement in understanding something.
Perfect. That's what Aristotle called it. Was perfect when things
Right.
cease to change. That's
Right.
what
Mhm.
perfect.
To reach perfection. Yeah.
That sounds like.
Tell me.
It sounds like it sounds very autistic.
Let's go back to let's
I'm
go back to
sure-
what Don Don said. What is no change, Don Don?
I don't know what that is.
I don't either.
I mean, it would be like the heat death of the universe or something. I guess.
Yeah, it'd be something crazy like that. I mean, like, so we have the idea of change. Well, what is its binary opposite? You know what I mean? Like,
Can't we think of
Status?
if everything in reality was to stop changing right now, and there was no decay, no nothing, just stop changing and stay that way,
Right.
then we're in a changeless.
Yeah, I
state.
can imagine it. That's easier to imagine than spaceless.
Oh
Right.
God, yeah.
spaceless is really difficult. I can't
Yeah.
even do.
Really,
I can't.
As spaceless as something spaceless that exists. Don. I can think of something.
I can think of tons of things that exist that don't have like depth, girth, no extended.
Well, like a
anything.
photon doesn't have length, width, and height.
Yeah. So, well, I'm interested. Give me an example.
I mean, I've been using this one ad nauseum, but I guess I'm using it justice.
Justice. Yeah.
But well,
So
it-
that's
sure,
fine. So concepts, essentially. Concepts are you can
But
imagine.
if you are a physicalist, they live in space, right? The concepts.
Do fields have space and girth and like they're spaceless? Right.
Well,
Let's
this
ask.
is
that's
why
a
I
good
said
question.
this is why I said it'd be like a Platonic form outside of
Yeah.
space and time, which would be spaceless. Again, I still feel as though what would that heaven look like?
it wouldn't look like anything because it
It
doesn't
wouldn't.
have space.
You'd have to
So
say
a
that it wouldn't look
field-
like anything, right?
A field occupies space. It's not doesn't have space. Okay.
But yeah, space again is the canvas for all of this, right? For concepts and everything. So I think we literally have to imagine a canvasless painting. And that would mean that there's action within it, or there's action being maybe forced on it, but there's no canvas to print it on. But that's a very fucking hard concept to imagine.
I think I can. I'm telling myself that I can imagine it, but I'm still using these ideas of change in space to
Right.
conceive of them.
I mean, can we conceive of a what is it? Of a 1 million sided die?
Wait, say that again. Can we conceive? Yeah, we can conceive of
Let me
that.
ask
you imagine it?
ChatGPT that, because that's a fucking good
I've
question.
been talking to ChatGPT while y'all are all talking here.
Yeah, I can imagine it, Don.
Can you actually imagine it? Like, see it in your head? A 1,000,
Yeah,
a 1 million sided die.
it would look like a sphere. It
No,
reminds.
then you were imagining a sphere, not imagining a 1 million sided
Well,
die.
it would look like a sphere. It wouldn't be a sphere, right?
I guess so.
Well, I mean, let's think actually of what a 1 million sided die would look like, right?
Are we talking about a 1 million dimensions side or just like 1
No.
million sides?
You've seen 6-sided die before. You've seen 8-sided die before.
Yeah.
Right.
Yeah.
So a 1 million sided die.
Yeah.
Just feel round to us, wouldn't it?
It would seem round for the most part, but it would still have its distinct surfaces. Of course, there is no such thing as a flat surface,
Yeah, there isn't.
but
I would love for you to
It
do a.
doesn't make 90-degree angles. That's a thing.
I would
I'm
love
sorry,
for you to
what,
do a. I was going to say I would love for you to do an episode on imagination at some point when we get into.
We will. I did one part in Imagination series
Oh,
with the flow state. Do you remember that?
Oh yeah. Oh yeah. Definitely.
So we've covered. Unless somebody else wants to go ahead. You good?
I'm good.
yeah, I agree. Fallibilism is key. Whenever I make a claim, I first of all I print the words up at the top of my site. And I
Yeah.
imagine what, and there's always the word tentatively in parentheses when I'm
Yeah.
writing these words out. So
And there's and look, and this doesn't mean. I don't think fallibilism means that we can't be strong in our convictions to the
Let's
things.
cover this for a second, Travis.
Sure.
Let's cover fallibilism. I think it's important to tell people about
I think
it.
fallibilism is very simple. It doesn't mean that we don't know anything. It just means that what we do know can change.
Yeah.
It just basically says that neither knowledge nor belief is absolutely certain. That's all
Yeah.
fallibilism means. And it's not making that claim. It's within that claim, it's saying that it can also be fallible, the fallibilistic of the
Right.
fallible, right? So, and Perry could probably take it away from me right here. Tell us about person and fallibilism.
I hate that you brought up that one conversation that you had with the one dude. Well, couldn't there be the negation of the negating?
Right.
Oh, that guy. Oh, my
Oh
God.
my god, that's what I think of every time when
You
when we
asked him a
talk about
perfect
this.
question. Can there be a presupposition of negating presuppositions? And he was like, no, I guess. I don't
He just repeated the same thing that I would responded to. But
Yeah.
what did you want me to take? What did you want me to take away?
Well, explain fallibilism and how Peirce saw it, because I know you did a good amount of studying on Peirce, right?
I never did a show on him, but I don't know what his words were on fallibilism. I mean,
We
I
can talk
can-
about some other people like Karl Popper was also a fallibilist.
well, let's talk about our ideas of fallibilism.
Yeah, sure. I was just gonna give the audience something to munch on. So let's talk about
or whatever.
this.
Yeah, we could
It
talk about
seems
whatever.
as though there's an infinite regress problem with it. So, according to philosopher Scott F. Aiken, fallibilism cannot properly function in the absence of infinite regress. This is interesting to me, so I want to understand what they're saying here. The term usually attributed to Pyrrhonist philosopher Agrippa, aka the Agrippine trilemma in Justification, is argued to be the inevitable outcome of all human inquiry, since every proposition requires justification. So that's what it's talking about. I guess now that I'm reading it, it's talking about the Agrippin trilemma. The justification problem. Are you an infinitist? Are you a foundationalist? Are you a coherentist? So,
Yeah.
and it's covering. And now that I see it, it's covering the problem of the criterion. So, that is the serious problem that we will always have, and I think that's why we have to be fundamentally fallibilistic.
Would we? So we would all agree. Yeah, exactly. We would all agree that like, whatever you are, whatever ist, whatever ism, whatever, you should first be a fallibilist. I mean,
I agree.
right? Like, this makes sense to me. Fallibilism is where dogma goes to die. So if you want to live like, if you want to be a dogmatist, if you want to be consumed by a dogma, maybe this idea that no matter what, I know that there's a heaven waiting for me when I die, and you'll never change my mind. Nothing could ever possibly change my mind. You know,
Mhm.
this incontrovertible certainty that I write about in the
Yeah.
new book. Fallibilism is where that goes to die. So if you really want to hold on to those feelings, then don't get into fallibilism, because if you do immerse yourself into it and you become convinced of it, those dogmas are not going to be convincing anymore to you.
No.
Yeah, I used to be jealous of those people.
Right.
What happened?
I realized that philosophical suicide and losing your curiosity was a hell in itself.
Yeah. A colorless world, a gray world.
Oh yeah, yeah, most definitely.
I think fallibilism. I think the beginning of science should be I don't know, and then from there you can follow the evidence where it leads.
You don't
I
need to
agree.
know.
Yeah.
Yeah. And that's one of the most beautiful notions in The Edge of Knowledge by Lawrence Krauss, and we talked about it on stage. But no matter what it is, interpersonal relationships, intersubjective space, physics, it doesn't matter what it is. I don't know is a fine answer to any of this, to any of it. It's a fine answer. And too many people think that it's a you've given up, or that's a dodge, man. No, it's not. It's a fine fucking answer by anyone who values wisdom.
Yes. If you're seeking the truth, then you don't want to. You don't want to set the goalpost for yourself and then walk yourself to the goalpost. You want to
Yes.
follow the evidence where it leads.
This is a famous clip where Richard Dawkins showed TV Fox News ex-host Bill O'Reilly to be a fool, because he would say, well, show me how God didn't do it, and then maybe I'll believe you. Like, it's like,
Guys,
oh,
unfortunately, I have to use the bathroom, so
It's
I will-
okay. This is
for
super
tonight.
informal. Go use the bathroom.
Okay.
Taste man. But yeah, I mean, I think any kind of any kind of situation where someone's obviously just shoveling in filling a hole with horse manure, instead of like something useful, you don't need the horse manure in there. Just leave it empty until something satisfies your epistemological standards.
Yeah.
It's okay to leave it empty. It's a fine thing by itself, empty. Like, fuck.
Oh my God.
It's kind of don't piss on my leg and tell me it's raining. We have all these little interesting things that people pass around, these useful memes, like and ideas that
Memes is how most people learn things today. Is the funny part.
right. Yeah.
Memetics in culture have always existed, but never since the age of the internet has, or the age of the internet, it basically allows everybody to learn through memes,
Right.
some kind of meme that gets passed around.
Yeah.
Perry, are you still with me, brother? Are you
Yeah.
gonna get tired here, or
An
'cause
hour,
I can continue all night?
an hour 15 is right about where
Okay.
my intellectual stamina starts to die down.
I love it. I love it.
So-
Let's not talk about fields or anything real quick. Let's just cover 1 second. I had a lot of things I wanted to cover, but I'm gonna condense it real quick. So let's just because we'll have another episode on physics where we start talking about the different branches and what quantum mechanics is. So just remember, guys, that in physics, you are trying to understand the forces. That's what we're trying to understand, because the forces are fields, and the fields have quantized packets that are particles, wave particles, if you want to call them that, because they're a part of the field. When you quantize an electron field, you get the electron, right? Quantizing something means to make a particle of, or to make an instance of, that can be measured, instead of just being free floating in the field. Um, it almost kind of brings Copenhagen interpretation to mind. But anyway, regardless, I thank you guys for coming to talk with me, because I love you. And thank everybody for listening and hanging out with us on the show. And please subscribe to my channel, which is Thomas Panner at the Pangburn Universe. Please subscribe to Pangburn, our buddy Travis Pangburn here. Just type in Pangburn in YouTube, you'll pull it up. And Don Prager, his channel is also a part of the Pangburn Universe. Please go subscribe there. And I guess we'll see you all next time. We love you.
Sounds
Love you,
good.
Thomas.